Hello everyone, welcome to today's Novedge webinar, Lens Design, Professional Landscaping Software for AutoCAD. This webinar will cover lens design main features like the extensive plant database and the terrain modeling tools and how to insert vegetation and civil work elements, including some animation tools to record virtual tours. Our presenters today are Francesc Salla, who is an architect and the product manager of VisualARQ and Land Design, and Elham Ghabouli, who is also an architect and has a PhD in urban and architectural management and years of experience as researcher, lecturer in landscape and urban planning. And now let me show you where to find lens design on the Novedge catalog. This is the product page. Novedge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service, and no headaches. And you can also buy Rhino at Novedge.com. And often we have specials. This week we have incredible discount on this 3D CAD workstation that can enhance your workflow, especially when you have projects that need a lot of 3D rendering. So check us out at Novedge.com. And I want to remind you that this webinar will be recorded and posted on YouTube and Vimeo later today. Now, without further ado, I'm going to switch the screen and let the team at Lens Design run their presentation.
Hi, everyone. Warm greeting from Spain. I'm going to present, do a short presentation of Lens Design, and well, I'm going to stress its main powerful features. Lens Design is a professional software for landscape design, and it has two versions, one for Rhino and another for AutoCAD. Both versions have the same functions and the same toolbars. Today we are going to review the AutoCAD version. It's a professional landscape software with BIM technology. It lets you to create 2D drawing, model your project in 3D, then it automatically lists the plants and materials, and continue, it lets you to create videos and images with animation tools. Lens Design is a useful tool for landscape architecture, of course, and also in green infrastructure design for civil engineering and for architecture, in urban planning, and in environmental projects, for example, for modeling the forests. So why to choose Lens Design? I'm going to stress its main powerful features. First of all, Lens Design contains an extensive plant database in 3D and 2D. The plant database lets you basically, has several features that lets you to select your adequate plant according to the characteristics, to the soil type, and different characteristics. Then any species has several representation, the conceptual, the detail, the elevation, and the crown type that you see from the 2D. Also, as you see on the top, we have these kind of different representation for the same plant: the realistic, the detail, the conceptual, and the elevation. Inside the plant database, there is a plant editor. When you search for any species, you can modify that with this plant editor. Also, you can modify the characteristics of any species. And finally, you can save it as a new species or as a duplicate of the existing species, but with another representation according to your desire. As you see here, you can shift from different representations modes just by one click, from the conceptual to the detailed to the realistic, and from 3D to 2D, all of them by just one click. Another reason that, which is another powerful feature of lands, is that lands design have powerful terrain modeling tools. These tools let you to create terrain by lines and points or combination of lines and point clouds. And then you can modify the terrain, you can create cut and fills, you can modify the terrain easily by control points, create paths inside the terrain, you can divide the terrain, and well, assign different material, different texture to different parts of the terrain. And at the end, you will have the list of earth moving operation automatically calculated by lands design. Also, you can import terrain. So by looking the location of your project anywhere in the world, you can find the place of your project, and then lands will import the terrain according to its own database of elevation. So by importing this kind of terrain, also in continue, you can import the 3D mesh of the same area, including the satellite image of the area. For example, in this example that you see, it's a project in Barcelona. And well, now we import the mesh with satellite image of the area. Okay. Also, there are dynamic documentation tools that let you to import the list of plants, the material, blocks, and earth moving operation just by one click. And also you can add the image of the species with the special comment inside the program, and we'll continue all the documentation process in lands design. In continuing also, it has irrigation tools that lets you to create irrigation plan of the project, and at the end you will have also the list of pipes and sprinklers and filters of the project. Also, lands has several hardscape tools that lets you to create parametric walls and curves, parametric paths, parametric fences, and also there are block library for furniture inside the program. And also you can import any blocks from supported programs, for example, from SketchUp or other supported formats. We have tools for creating animated videos and realistic images. These tools include walk mode, visual simulation, sun and shadow tools, render, and filter. There's an image filter inside the program that lets you to filter your image at the end. The design process with lands design is summarized in this short video. As you see, you can import the terrain, or you can elevate some curves and then create the terrain according to these elevated curves, as you see. And then you can zonify the project, or you can modify this terrain. Then you can zonify the project in different zones. It gives you the area and the title of the different zones. You can assign different material to the different zones, as I said. Then you can insert plans from plant database in different arrangements. It can be in a row, in the forest mode, individually. And the plants can have natural variation if you choose it. Well, as you see, you can create forest. And well, in continue, you can insert the hardscape elements, the different blocks, or like walls, fences. And well, you can modify their place, or well, everything easily. Then also there's a nice tool inside the program that lets you to shift from 3D to 2D in any moment of the project just by one click. So you can modify the project in 2D environment or in 3D as you wish. Okay, as you see here, then also continue, you will have the list of plants, materials, irrigation tools, earth moving operation, etc. Well, they are calculated automatically, and finally you render the project. Okay. This is the workflow of lands design. Basically, you can start your technical drawing in 2D environment in AutoCAD or in Rhino. It's up to you. As I said, there are 2 versions of lands design. Then in continue, you will model your project in lands design, and it has BIM technology, so it creates also documentation for you. In continue, you can have visualization with your favorite render engine, with virtual reality, or you can print it in 3D. You can also export your data directly from the lands to Excel or to PDF. You can also import your drawings, export your drawings and print them. You can also have collaboration with other softwares, for example, with SketchUp, Revit. You can import or export your model to these programs. And also you can import GIS data, DEM files, digital elevation models, or topographic point clouds directly to lands design, and lands according to this imported data will create the terrain. Okay, up to now, do you have any question?
Thank you, Elham. That looks wonderful. Yeah, I forgot to mention at the beginning that if you have any question, just feel free to ask them. There's a question tab in the control panel, and comments, questions are welcome throughout the presentation. I think now Francesc is going to take over. I'll make him the presenter, and let's get into it. Let's get inside lens design. So exciting. Here it is.
Okay. I'm gonna minimize the screen with all right. So we're going to see now a live demo of what Elham has described in this presentation. So an overview of the main land design features on AutoCAD. Okay. So we've got here already some project, some small garden. And if we take a look at the land design tab here, we can see all the commands that are available with the program. So basically here we have the shortcut to open the plant database, from where we can check all the 2,000 species that are included in the program. Here we've got some commands to insert vegetation elements. Okay, we can insert plants individually or arranged in rows, in forests, or in a paint mode. Okay, or we can insert shrubs or ground covers. Then we've got some civil work objects. We can insert walls, fences, stairs, paths, or rows of elements that we can browse from the urban furniture library. Okay, so we will see the blocks available by land design. Then here we've got all the terrain modeling tools, so we can import them from the web, as we have seen in the presentation. We can elevate contours to generate terrains afterwards, and then from these curves, or could be also points in the 3D model space, we can create a terrain. Then we've got some commands to do operations on the resulting terrain, so we can add paths, we can define new contours, add holes, add cuts and fills. Okay, there are some operations that are available to change the terrain topography. Then we've got also some watering system tools. Okay, we can insert pipes or sprinklers that can be also arranged in an array way. We can show some shadows on plants. And finally, we've got other documentation tools to generate lists of the elements we've got in the model. Okay, or well, some plant labels. Okay, plant photos. Well, elevation marks, labels, slopes, or zones, okay, to quantify the areas in our project. And finally, we've got here the edit panel, okay, that is divided into 2 tabs, one for editing everything that we've got here in the model, and another one to do some animations. Okay, we will be able to record some virtual tours through the project with a very few steps. All right, we'll see that at the end of the presentation. And then we've got also some other commands to navigate interactively through the project with this walk mode, okay, or set one viewpoint to define, some positions for shooting renders. And there is also included an image filter application that lets you select the render result or any other image and apply some effects for some kind of post-production, okay? But let's take a look at the Lens Edit panel. Okay, as I said, here's from where we can edit all the objects that we select in the model. If nothing is selected, then we can change the document properties. So we can change here how we want to display these trees that we've got in the scene. Okay, we can switch from realistic representation to elevations, okay, conceptual, detailed, or back to realistic. Okay. Also, this realistic has two different representation modes, one in 3D and another that shows the wires of the geometry. And it would be convenient if we have like a large number of species, a large number of trees in the model, and we still want to work smoothly. Okay. Since this is a small project, I'm gonna switch to 3D. All right. And just notice here that we've got here the possibility to decide in which season we are going to render the scene. Okay, so basically, this realistic representation mode of plants can handle different appearance. So they will show differently if we shot the render in spring or in winter. Okay, and actually with the preview, they already show up some differences. For example, if we switch to winter time, okay, some of the species already have a preview representation for the winter, like this species here. But since we are in spring, at least in Spain, I'm gonna select the spring season by now. All right, and also we can switch from 3D to 2D representation to see the project in 2D. Okay, so I'm gonna work from 2D, from the top viewport, okay? And when I select this 2D representation, all the lands elements will show using a different representation mode. So basically, the trees show the 2D crown, okay? The zones show a hatch pattern, okay, instead of texture. And some other elements like ground covers, they also show, a hatch pattern with this wavy contour. And later on, when we generate terrains, we will be able to see the contour lines. Okay. So the idea is that if you feel comfortable still working in 2D, you can keep on doing it. You define all the project design areas and guidelines. And at the end of the day, you can just switch to 3D and take a look at the project in 3D. Okay, which looks way nicer, okay, for presenting it. All right, so some of the things that we will do, actually, when we start working on any project, we usually define the areas, okay, the guidelines of the project design, and we start zonifying it, okay, to get an idea of the areas that we will need. Okay, so we'll start by inserting here a zone. So we will use the zonify command. Okay, I'm gonna pick a point inside that area, and I just need to define here a title for the label of this area and to the hatch pattern. Okay, I can also select here a material, so I can browse for the library of materials that Lens Design provides. Okay, to select a different one, but this one will be visible when we switch to 3D. Okay, when you're working in 2D representation, the zones are represented with a hatch pattern. So I'm gonna finally select the position of this level. Okay. Later on, when an object is created, like this zone, we can edit its features from the edit panel. So we will be able to change here the label name or the dimensions of the text, the hatch pattern, and the rest of the features. Okay. just to take a look at the 3D, we can see now the material on top of this area. Okay. Later on, we will generate a list of all the areas that we've got in the model, including this one that we have created. But let's switch back to 3D and watch this project from the 3D view and insert a plant. Okay, so I'm gonna run this command, plant command. Well, the insert options are basically the species that we need to use. Here, since we've got a few species already, we can see them listed here. But of course, in a new document, this will be empty. So you would need to browse for the plant database to search for your desired species. And you can, there are many ways to do it. So you have all these filters that let you select or search for one specific plant. Okay, and you can just pick the characteristics, the leaf type, flowering, and any other details that meet your requirements. Okay, and here you can see the list of all the plants that meet these requirements, and you can see already the different representation modes for each species. Okay, we've got here the 2D crown, the conceptual and detailed shapes, and the realistic, which is the one that you know, has all the textures and materials for shooting a render of this plant at any moment. I will just clear this search. I'm gonna just look for a lemon tree. Okay, so we can just type it here, and well, I'm going to check for the properties of this species and add some details. Basically, you can, if there is any species that is missing in the plant database, you can actually create them from scratch. Okay, you could click on this button to create a new species, and you have here all the fields, you know, to fill for generating a new species from scratch. Or we could duplicate an existing one and modify the copy. All right. So, well, in this case, I'm just going to check the properties of this lemon tree. I'm gonna click on this button to enable any change. I'm not going to touch any of these details, of course, but I would like to change, for example, the display of this plant in 2D. So here I can browse for different crown, 2D crown, according to all these blocks that are stored in this folder. Okay, so I can change any one, any desired one. Okay, let's choose this one. Maybe it's more appropriate for a lemon tree. Of course, if you're using your custom, you know, 2D representation, you can just select it from browsing it from your computer. All right, so it's totally customizable the way you want to represent plants in 2D. And well, we can do the same with the conceptual shape, with the detailed, but maybe here is interesting to check for the realistic plant. It's basically a plant that has this NXT file format, okay, and we can browse for different formats, okay, different files. Actually, the file format is AR plant X, okay, even though they are called NXT plant. And we have a bunch of them, over nearly 600 different representations, okay, for the realistic plant. I'm gonna cancel this, but if you want to still modify one of these files, you can do it from the plant editor. So from this button, we can launch this plant editor, all right, and you can just play with the, you know, with all these parameters to search for the real appearance. Okay, more realistic appearance according to the real plant. So you can customize this realistic representation with all these parameters, okay, as you wish. And also you can assign here an image for the trunk, okay, or for the leaf or the fruits. And also just notice that here we've got different definitions that they are attached to the different seasons. Okay, so we can well, check them out. We can see that first definition is related to spring and late spring, and we can check the other ones. All right, so each one has different images for the fruit, for the leaf, and they will be used when we shoot a render in one season or another. Okay, and actually you could create like a new definition and assign it, in this case, to the only season left, right? And I would like to show you also some of the templates that are available if you want to create a new realistic plant, a new NXT plant from scratch. So you could just select any of these templates, and well, just play around with all these parameters until you find your desired appearance. Okay. All right, I'm gonna close this by now. And I'm not going to edit anything else because I wanted to insert this species actually. So I'm gonna select it. Okay, now I need to select the head. All right, just notice that we've got this natural variation and random rotation that will make that if we insert different instances of this lemon tree, they will be rotated and will be slightly different in dimension, so they won't look exactly the same object. Okay, so I click OK and just need to define a point to insert this plant. Okay, now once this plant is inserted, I can just select it and change, for example, the dimensions from the edit panel. Okay, or we could change the plant from here, browse for a new one. All right, and do any change at any time. All right, we'll get back to the vegetation commands. Okay, first I would like to generate a terrain. Okay, so you will see how the plants are projected on top of the terrain as I do this. Well, there are different ways to generate terrains, as we have mentioned already. We can import them from the web, also from digital elevation model files, from curves or points in the 3D model space. So basically, it would be a common scenario to have, all the contour lines just in a flat position in the same plane. And in order to create a terrain from these curves, we need to elevate them. So what I'm gonna do now is run this elevate curves command, okay, which asks me to draw a line from one point to another, and all the curves that intersect with this line, with this cross line, will be elevated according to an increment. If we click on the apply button, we will see how this changes. All right. If you want to change that into any other value, you will see the difference. Okay, but I'm gonna put this back to half meter. Okay, so when you are comfortable with this, you just close this dialog, and now we've got the curves in the 3D model space. Right. So now I can just run the terrain command, which is a mesh generated with this Delaunay triangulation method, right? So it identifies all the points of these curves and generate a mesh, a triangulated mesh. But we can also use this gridded surface shape to triangulation to determine the size of the cell of the resulting mesh. Okay, the smaller this value it is, the more accurate the terrain will be with this data. Okay, all right, I'm gonna say okay, then select all these curves. All right, and hit enter to generate the terrain. I have these curves in one specific layer, so I'm gonna hide them by now. It's what's that, terrain contours, because now I want to highlight that we can still modify the topography of this terrain just by changing the position of these control curves. Okay, and well, modifying them as if we were modifying the original curves, contour curves. So we can change the topography of this terrain by these control points. And now some operations that we can do on the terrain are, for example, we can define a new boundary. Okay, I already have here a curve, so I'm going to use this for defining the new contour of this terrain. So under the lens design commands, I've got this boundary, peak boundary command. So I need to select the terrain, hit enter, select a closed curve. I mean, it's always recommended to follow the instructions in the command line. Okay, and the terrain will fit to to get this curve as the boundary limits of the topography. I would like to show that if we switch to the representation, okay, we will see the terrain curves, which are different than those that we used for generating the terrain. Okay, they are not linked anymore. We could actually delete these original curves because these curves are basically a result of the terrain topography. Okay, if we select the terrain, we can edit it from the edit panel. So we could change the cell size, for example, or we can change the way these contour lines are generated. So I'm gonna, rather than defining a number of contours, I'm gonna set distance between contours, okay, and maybe say 20 centimeters because it's like a small terrain. All right, and there is one interesting feature here for the contour to well, enable these index contours every certain number of contours. Okay, so you can basically assign different line type, line weight, or color every certain number of contours to get a better feedback of the topography. Okay, in 2D. All right. If we go back to the 3D view, okay, there is also an option to visualize the 2D and 3D representation of objects simultaneously. And this is something that can be done with this button over here. Okay, so now we also get a better feedback of the terrain topography in the 3D view. All right, I would like to also just emphasize something. Okay, so if we place now trees on top of this terrain, okay, the trees will just determine the position of this terrain and will be created on top of it. Okay, so as you can see that now the trees recognize the position of the surface and they are placed on top of it. And actually, for any modification we do on the terrain, the trees will update. All right. Now let's generate here some other operation. So for example, I'm gonna generate a path. Okay. So I've got here some auxiliary lines. Okay, one that will be used to generate the path. So if I switch to wireframe, I will be able to see these lines that are hidden by the terrain. So if you can see this blue line, okay, here, which is actually in the zero elevation, it's a flat curve. I will use it for generating a terrain. But first, I need to elevate it into the desired position. So the first thing I will do is to adjust this curve to the terrain from this command here. This, in the same way as trees were projected on top of the terrain, this command puts the the curve, the blue curve, on top of the terrain, as you can appreciate here. And now, I mean, we could also change the the position of the curve, just pulling the control points. But now we can apply a path that will make the terrain fit, the position of this curve according to a width. So I can run the path command here, select the terrain, define a land, a path width. So I'm going to say 3 meters, and an angle for the slope in which the terrain will meet the boundaries of this path. Okay, 45 is all right. And finally, need to pick a curve. Okay, so select this curve, and now as you can see, the a subdivision is generated in this terrain, okay, with according to a width. All right. We'll switch back to realistic because, you can appreciate here the different, the land movement that has been generated with this operation. And something that we can change here to have a better feedback of the area of this path is changing the material of this subdivision that is generated after this operation. I can change the subdivision from here, and under the materials tab, I can select one of the textures that are available in the library of materials. Okay. So I'm gonna select, for example, this gravel. All right. Of course, if you're using any rendering engine for AutoCAD that has its own library of materials, you can select them. All right. But in this case, I'm just using one of the materials that come with the program. All these operations that we have done, the boundary, you know, the curves that were used to generate the terrain, the path, this is something that is stored in the terrain geometry. And we can check this under the input data. So we've got here the A11 contour line curves. So we could pick any of them and remove it. So the terrain will be recalculated, okay? Or we can select this path and change the width, for example, all right? Or change the cut angle, cut and fill angle. So any of these parameters can be modified later on, all right? Or we could just remove this path if you want to keep the original terrain. All right, so once we've got the terrain, maybe it's a good moment to insert here a few trees, okay? And I will show you the forest command. So I'm gonna work from the top view, and well, I'm gonna work into the, so we can display this curve, okay? That it is actually in the XY plane. I mean in the zero elevation. But I don't care because I will use it to generate a forest that will be automatically projected on top of the surface, on top of the terrain. Actually, I'm gonna move this tree in a different place. Okay, there we go. And well, I'm ready to run the forest command that is asking me for a plant species in the same way it asked me before for a single plant. Actually, I'm gonna just select one of the existing species. And here we need to define the approximate height. It is important in this case to make sure the natural variation is enabled, because while in a forest, not all the trees have the same height. Okay, so it will give a more realistic feeling to the final scene. And under the forest tab, we can define the parameters of this forest. So we can define if we want this distribution by a number of units. Okay, we can also set the minimum distance among units, or using this array arrangement. Okay, so I'm gonna say, let's, for example, 30 units, and well, click OK, and finally select boundaries. I mean, I could draw, the boundary on the fly, but I will select these boundaries from the command line, pick this curve, and now the forest is created within these boundary limits. Okay, this is a random distribution, of course, but if you don't like, you can just go to the forest and click redistribute as many times as you wish. Okay, and taking a look at this in 3D, if we go to the 3D view, you can see that the forest is projected on top of the terrain. Okay, great. Let's insert now a ground cover. Well, let me show you before another way we can distribute plants. Okay, so if you like to distribute the forest in an array way, we can define here the separation among every unit, and as a different method to distribute the plants. Okay. Also, you can combine different species, all right, in one forest or in a plant row, for example, just by clicking on this arrow to define more species. Okay, and when you do this, we get this list, so we can select each one of these plants and change here all the species, all right, to have a combination of a forest that combine different species. All right, actually, I like the random distribution, so I'm gonna pick this one for this forest. Now, let's insert a ground cover. Okay. So I'm gonna work from the top view again in 2D, and I will use this ground cover command that, unlike plants, it uses a different definition. I mean, different file format for the realistic representation. Okay, and also in 2D they are presented with a hatch pattern. So I have here all the species that have this specific representation. Okay, and well, I need to click OK, and now we'll define also the way it will be displayed in 2D. And now I just need to draw here the contour for filling the an area with a ground cover. So I can choose any of these options. I mean, I could have also a boundary curve generated in advanced, but I'm gonna just generate a rectangle on all this area, for example. Okay, and well, you can see that ground covers are generated with these contours. We can change, the limits of these contours just by pulling control points of them. And if we take a look at this in 3D, okay, we will be able to see all these little guys on top of the terrain. All right. So the ground cover also has some parameters to change the density or change the plant scale, okay, in order to control how these plants will be displayed in the final render. Great. Now let's take a look at some of the CivilWorks tools. Okay, so I'm gonna work back in 2D. And first, I'm going to insert a wall. Okay. Well, I've got already a wall here generated, but not in here. I just have here some curves. So I'm going to run this command. A wall is a 3D object determined by a thickness and a height, okay, and also a justification, which also includes a material when we switch to a 3D representation. And here we just need to select either a polyline or just draw it directly here. Okay, so I'm going to draw it here very quickly. And well, taking a look at this in 3D, we can see the wall created here. There is a match properties command that is here. It's actually called copy properties from another object that is helpful in this case to if we want to make this wall equal to another wall. So I'm going to select this one and the wall will be equal. Just notice that the alignment is not the one I expected, but this is something that we can change from here. All right, to invert its direction. All right, now let's insert an object from the library, from the urban furniture library. So we are going to browse the different objects that are available here. We can see that we've got some fountains, some games, or urban furniture. All right. There is also information of commercial products that they offer 3D blocks in their websites. Okay, so you've got here some links to their websites and get information about them. In this case, I'm just going to insert some of these swings. For example, this one. Okay, I'm gonna insert here in this playground area. All right, and well, all the blocks are something that we will be able to list later on. So now we could actually show some of the 2D tools. I'm going to switch back to the top viewport and 2D. And since we have inserted already plants, zones, blocks, and and terrains, we are going to list all this data. Okay, so first I will insert a plant list. All right, so I define the insert point. That shows me a live list of the units of the plants that we have in the model. That means that if we change the number of units for these forests, okay, just pay attention to the value under Acer and the other one. Well, it already changed. Okay, before I could finish the speech, so we changed this value. This species just change a number. Okay, so the lists basically are dynamic with the information that we've got in the 3D model. So we can also insert a list of zones. Okay, we've got also the playground zone that we inserted before. We've got a list of urban furniture blocks. And finally, I will insert a list of terrains. Okay. We haven't included yet the command, so I'm gonna play the command from here, list, and you get a better idea of all the objects that can be listed. So I'm gonna run this list terrains, okay, to also insert a list of terrains in the model. Just notice here that we can control the amount of volume, land movement that has been added and subtracted after that path operation. Okay, so get an idea of all the land movement on this terrain, comparing it with the original one. And of course, we can. There are some options to edit, the appearance of this list. So we can here determine which data, which values we want to display. For example, in case of the ground covers, it's interesting to see the density. All right, and also we can define like different ways to show this table. And finally, we can export that to Excel. Okay, we can print that. And we have a couple of formats to export it to HTML or XLS to open it in Excel. Okay, I'm gonna cancel this by now. And well, let's see some more tools for documentation. I was mentioning these plant shadows. Okay, when we enable them, we see these shadows drop under the plant, so it gives more realistic feeling in the 2D drawing. Okay, and well, just going to hide them by now. Or well, we've got here also this plant level command to select a group of plants, for example, this row, and get a label with a number of units and the index of the unit. Actually, if you check the plant list, we can see the index value for this species, but also you can change that and show the initials or the name instead. Okay, it's up to you. And obviously, if we edit this row, okay, for example, we go to the row and say the separation, it's 1.5. Okay, we'll get this value updated with the number of plants. Now, I would like to show you some of the other commands. For example, the plant photo. So we can select one species, for example, this lemon tree. Okay, and we select one of the pictures that are automatically searched from the web, or if you have your own picture, you can also browse it from your PC. Okay, and finally insert here a picture with an arrowhead pointing the indicated plant. And also would like to show very quickly the slope tool, especially in terrains is very useful. For example, if we select, well, first I will make this text size smaller, but if we select this curve, we can get an idea of the slope on this path. Basically, it takes the start and end point and calculates the slope. All right. It doesn't take into account the variation of the slope in between, though, but only the slope from the start to the end point. But also, if, for example, we run the slope command again and we use this polyline option, we can enable the slope. I'm gonna change the size of the text again from one specific point to another. Okay, you can see that we have a more steep slope in this part of the terrain. Now, we have seen many of the documentation tools. Now maybe it's time to create short animation. All right, so I'm gonna switch back to 3D. Okay, show the model from perspective, and I'm gonna show a layer where I've got a camera path. Okay, and you can see it here. It's this line over here. Just let me switch to wireframe to be able to select it more better. And first thing that I will do, because this camera path is actually also in the zero elevation. Okay, So what I'm going to do first is to elevate it to the terrain. So I'm gonna adjust it to the terrain. Okay, so it goes through the path as well. And now I will also elevate it a little bit. So let's say I will elevate it, for example, I can switch to realistic. And now I'm going to, well, go to the animation tab, select this path option. So I will select this curve that I have as the camera. Okay. Sometimes it's hard to select this, so I'm going to switch to wireframe again to be able to select the curve. Okay. And let me check last time if I've got the gimbal to move this in the vertical axis. Anyway. Okay. So I select this path. Okay, I'm gonna select this curve. And now I can switch back to realistic. And under the animation options, I can define here the name of the animation, the frames per second, and the total duration of it. Okay. So we've got some other features to play this animation by just looking forward or looking to a fixed point or to another curve. We've got also some options to enable some sun motion, okay, that will be visible when we shot a render of this animation. And finally, we've got here some other camera commands and the AutoCAD display. We can choose between the AutoCAD display or the AutoCAD render that we are using here. So you would finally save this animation in one specific folder, and here we can play the the preview of what we see here. So excuse me because I wasn't able to elevate that curve, and that means that we do this animation on the ground. Okay, excuse me for that. But yeah, wherever this path curve is located, we will be able to to do the animation there. Oh, here it is finally. All right. So we can play the animation again, okay, and have the curve in a higher position. So this is just a preview of how the animation works, okay. But of course, if you shot a render, instead you will get a nice view of this virtual tour with renders. So just to end, I would like to show also the walk mode, okay, which is a nice command that puts you on the ground, okay, it puts you on top of the terrain surface and lets you navigate through the project with a cursor and keyboard keys, okay. So you can just present your project navigating interactively as if you were there. All right, and well, just to finish, I mean, I don't have time now to show the render to see the results. I would just like to show some of the projects that are in the gallery, in the website, just to get you an idea of the results you can obtain using lens design on AutoCAD. Okay, actually here there is a mixture of projects that have been used with Rhino and with AutoCAD, and but you can check them out to get the quality you can obtain. All right, so maybe we have time for some questions. Barbara?
Yes, yeah, there's no questions at the moment, but we're waiting a couple of minutes just to see if some pop up. Don't be shy. This is your chance to interact with, lens design's developer. So I think it's a valuable time. And yeah, that was great. Thank you so much, Francesc. While we wait, for question, maybe I'm going to show our webpage for a second and see. I want to show everybody. See if my screen, you can see my screen now. Let me know if you can see my screen. There you go. Okay. So I want to thank everybody for attending the webinar. And I want to show where you can find lens design at novedge.com. This is the lens design product page. As you can see, lens design works for both Rhino and AutoCAD. Today's presentation was about the integration between lens design and AutoCAD. It's a very new tool and very valuable for landscape designers that are really accustomed to AutoCAD, and it could really take AutoCAD to the next level. I also want to show everybody that we have a special promotion for CAD 3D workstations to go even further with your workflow. And if you missed today's webinar, you can watch it again on our YouTube and Vimeo channel as early as this, probably later today. I'm still waiting for question, but I don't see any question. I think you were pretty clear, Francesc. Thank you so much for this presentation today, and thanks Elham as well for our introduction.
You're welcome.
And have a great rest of the day or night. And looking forward to talk to you again soon. Bye bye, everybody.
Have a nice day.
Bye bye.
Bye bye.